All right. Now we have completed time series. Now we are stepping on to the last chapter, number 7, wherein we will see about probability, normal distribution, estimation, and hypothesis testing. How this is all we are going to see. We will see one by one. See, don't use mobile phone here. Try to focus. If you understand what I'm telling you practically, if you catch this and write also, no problem. Right? Understanding, listening is also a vital key for succeeding in exam. Yes, Mister, we started already. Come up, okay? Focus here. Yes, the last girl. Are you listening, dear? We are starting the last chapter. Please focus. Don't use mobile phone. Okay? So this is covering ministry outcome 5 and 4. This is the last chapter. It will be little lengthy. Now here, first I will be discussing about probability. Probability, we are going to study by dice, coins, and playing cards, right? Now, why are we studying with games? That we have to we have to understand. Probability, die, playing die, this is the die. Can you see here, Isa? The red color. We used to play game, right? Maybe snake and ladder or whatever. What number is coming, the coin will keep on move. Suddenly it will come down in the snake and ladder game. Like that we study. And also any football match or any what I can say, any game, whenever we begin, we used to throw coin. So heads comes means which team will begin first? We begin up. Or maybe playing cards or maybe any other instrument we use for probability study. So why are we using? It is to understand. Like for example, now we are paying insurance to car. This insurance rate is premium more, correct? Not very less, it is more only. It means the accident level has increased, that is why. Now, if the accident level is coming down, then you can see premium rate also will go down. This is the study impact. They decide based on the event which is happening. That is the probability study. What is probability? An event which is occurring, how many number of time. So we study by using dice or maybe coin or through experiments. And we come with an outcome. So that study is what we call probability study. We are doing some experiment, we apply this, due to this is how we come up. Like for example, paying car insurance premium rate or whatsoever. Okay, so that is why in this chapter, the first one, probability, we are going to experiment with certain game type of strategy, like using dice, coins, cards, all this we will be seeing. Marble, okay, student grades. So this is for our understanding and how it's impact in our real life. That is why we study this chapter. So let us move inside. What are all the things we are going to see is about the meaning of probability, what are the important terms, what are the various types, sample space through experiments and events, probability rules and addition theorem rule, and we are going to look into problem, that is probability using dice, ball, marble and a grade, and also probability, that is practical problem using playing card. You know playing card? Card malum? Don't worry, I will show everything. Okay, then you will understand. And also we are going to focus on normal distribution, the summary of property of the theoretical normal distribution, Z table value. Here we will be giving Z table, that value inshallah. In the question paper itself we will give. From there you need to take and calculate. So how to do also I will tell you. Then Z score problem. normal distribution practical problem, Z value, then estimation, hypothesis testing. Finally, we come up with problem with confidence intervals. These are all a broad area. Briefly, we are covering. That's why this chapter will be little lengthy. Now, probability. What is probability? It is a measure of likelihood of an occurrence of some event. Some event, how many time it is occurring. You are doing with some experiment, maybe with dice or coin or whatever. That is what we call probability. Able to understand? Now, suppose if I say there will be rain in evening, what is the probability? Maybe, that's all. We can say maybe, may not be. In news, they are telling there may be, they don't say there will be, there. They always say there can be. There may be rain or thunder shower in this area, in that area. Study based on the movement they predict. How the cloud is moving, well, we don't know. If it is moving, sometimes it may change direction. Sometimes they say in this direction, it may go to some other area. Just all roughly we can say it may rain in evening, but compulsory it may not happen. So they study based on the study, either it is a climate or maybe a business, how many times this event is occurring, they try and fix this is what you need to pay a price. So that is what we call here probability, measure of likelihood of an occurrence of some event. It can be anything. How many time it is occurring, we are studying using experiments. Okay. Now here we have to understand it is denoted as probability of A. P of A, this is a real number between 0 and 1. So here probability of A, it means an event can happen. If it is happening, we say it is 1. If it doesn't happen, we say 0. That's all. Event happened, for example, today evening rain. Happened means 1. It's not happening, it means it is 0. So this is what we need to understand. Probability of A, an event occurs, we say it is 1. Doesn't occur, it is 0. So we say with the formula probability of A, it can be lesser than equal to 0 or lesser than equal to 1. Happened is 1, not happened is 0. So sum of all possible events, whatever events you are taking, A1, A2, A3, we take like this, it should equal to 1. Equal to 1, something happened. If it is coming 0, nothing happened. So this is how we calculate using formula. Okay, you no need to save this in mind and all, but you should understand. So number associated with an event intended to represent its likelihood, chance of occurring, and degree of uncertainty, and so on. Like the rain I told you. How it will occur, we don't know. When it will occur correctly and all, we cannot say, but we can forecast. It can happen. It may happen. Exactly, we can't tell. It may delay or it may happen. So chances of likelihood. How much it is going to happen. Is it going to happen sure or unsure? It is unpredictable because nature. We cannot predict exactly it will happen, but it may happen. With our mind, we can just predict, okay, based on some experiments. It can or it may not happen. If it happens, we say the result is 1. If it doesn't happen, we say it is 0. So this is how we take it up with a formula and we come out with a conclusion. So where all this probability people are studying, it is from the origin of game of chance. That's what I told you. Rolling a dice or tossing a coin or using marble or using cards. This is all has come from the origin of game of chance. From there only they have taken this probability study. Like for example, taxi stand? Malum taxi stand? Taxi malum? We have a taxi stand, correct? Where you see a lot of taxi will be standing. Why this taxi stand not available more? Why only in particular area? Why? Now, if you see Shinas roundabout, we have taxi stand, correct? We can see lot of taxi will be there and there is a place where you can sit also. If you see Sohar, they put AC taxi stand, you can go comfortably, you can sit in AC, then your taxi ready, you can go. Right? Now, this taxi stand is not available more, only in a particular locality after a certain kilometer only they are keeping. Why? This is one question. Another question, a bus is coming from Dubai and you see it is not stopping everywhere. It has a limited stop. First it will stop in Akkar, then directly it goes to Sohar. Am I right? Then from Sohar, it goes somewhere in, I don't know, the area. Before Muscat, there is one stop, then directly airport. Why like this? Why? We have bus stop limited. Taxi stand, not every frequent for every kilometer, certain kilometer. This is the study. Probability. Where people are more, where the traffic is more, there we need. So they study the probability. Based on the probability, okay, Shina's roundabout, taxi stand. Then the next point, people are not more. Say, next roundabout, you can't find. So you have to go to the next point. You got the point? Depending on the size, study, and how people are coming frequently, they use the probability and they make it. Clear? Then in transport, if you see, we don't have train. You know train? Inshallah, it is going to come very soon. Maybe everything is ready. I don't know when they will execute. Okay. Train is coming. Train will not stop everywhere. Limited place only they will stop. Clear? In that stop, you see, you will have sometimes, if it is a main station, more number of ticket counter. Some place only one or two ticket counter. Why? You know ticket? If you want to travel, you need to book a ticket. Some place you can see more number of counter. Okay, let us forget bank. Let us take a bank. In a bank, if you go to Bank Muscat Sohar, more counter mojud. But Shina is only less. Why? Very nice. That's what occurrence, chances. How is the people coming? Depending on that, counter will be open. Size will be bigger. Demand more, people more, size more. That's all study by using probability. Probability study. How many number of time people are coming. How many frequently they are visiting. Depending on that, counter also will be zyada. You got the point? Same way for booking a ticket in that is railway station. You can travel Dubai, you can see. Right? Electronically, if you want to book, some places will be less, some places will be more. It's depending on population which is using. So they study this, how many times they are coming. Depending on that, how we can utilize. What is the time taken? All this from probability study only. So depending on the study only, they are doing this kind. It is implemented in business or whatever various fields. They are using it up. So the main origin, it has come from game of chance. So let us look up into the meaning of probability. Numerical measure of likelihood of an event. I told you, tossing a coin. Coin has how many sides? You know coin? Coin malum? Isa? You don't know coin? Rupee coin, anyone has a coin? 50 paisa or 25 paisa? Anybody has a coin? I don't have, yeah. What to do? You have, right? I will give it back. Don't worry. Have it. Oh my God, this fellow. What do you see here, Isa? Oh, thank you, thank you. What is this? I don't have magnifier glass. What is this? I don't want number. Coin. What is this? It's a coin. It has one side and another side. One side is head, another side tail. We call tail. Correct? Now, if I toss this, is it head or tail? You tell me head or tail. I don't want amount and all. It can be a head, it can be a tail. So the probability of an event going to occur is only one. It can be either a head or tail. Only one outcome is possible from the coin if you toss it up. Got the point? It can be a head or it can be a tail. So only one thing is going to happen. That is the probability. That's what we call probability. Coin is having two sides. Outcome is only one. It can be a head or it can be a tail. It can be favorable for one team or it can be a problem for the other team. See, if you see football, Kura Malum, football. So if there is a match between team A, team B, the referee will toss the coin. Okay, they will call the team captain. What do you want? Head. What do you want? Tail. Okay, right. He will toss. Head comes, they will kick the ball. Coin. So coin is deciding the match. Got the point? This is how they are using it for the study. How many times when you toss, how many times you get head? How many times you are getting tail? It's a study, experimentation. Okay, you have one coin. If you toss two coins at the same time, whether you get two heads or whether you get two tail or one head, one tail, what happens? Experimenting. So using this games like using coins or die, we are just experimenting how it works. It can be utilized in a business or it may be in a field of science or whatever. From there, they are taking this and applying. So that is why we study this probability technique. Okay. So numerical measure, number is definite, or likelihood of an event. For example, A is impossible event, then probability of A will be 0. If it is impossible, we call it 0. But if there is a sure event, it is 1. Coin tossing is a sure event. We can't say you will not get head or tail. There is one event possible. But if you don't get in some other experiment, not in the same I'm telling, in some other experiment, if it becomes impossible, then it is 0. So the probability scale lies between, you see, 0 and 1. This is the scale. If it lies in between, it is 0.5. Starts here with 0 and 1. 0 means impossible. 1 means sure there is an event occurred. So this is what we study from the probability. See, event never happen or event not, that is event and not event. Always, if you get 1, it means something happened. So this is how in the probability scale we measure it up. So experiment. This is what we need to understand. Important terms. Now experiment is defined as a process that generates or provides an outcome. Yes, there is a result. Now I tossed a coin just a while. So if you toss, either you may get head or tail. This is called experiment. Clear? Or rolling a dice. You may get any number. You may get 6, you may get 1 or 5, whatever. But die has 6 sides. 6 number, 6 sides. 2 sides means the probability is going to be 1. 6 sides also probability is going to be 1 only because the outcome is only 1. So this is what we call experiment. You can experiment with any example. So the sample point is an individual outcome of an experiment. Sample space is a set of all possible sample point in an experiment. How to understand? I will tell you. Example, tossing one coin. The possible outcome or the sample space will include head and tail. That's why I told you. Coin is having one side head, other side tail. Clear? So in this, when you try to toss, you will get only one result. It may be a tail or it may be a head. So this process of experimenting is what we call experiment, and the sample point is head or tail. Because coin is having 2 sides. And if you take a die, it is having 6 number. It is having 6 side, 6 number in the case of a die. That is a sample space. So let us see with some examples to understand clear. Now, before going that, we need to understand what is classical probability. Now, here it uses sample space to determine the numerical probability that an event will occur. How? Now, we need to assume all events have the same probability of occurring equally likely. Now, for example, can you see here? Toss a coin. Probability of head is 1/2. Now, if I ask you, what is the probability of tail? I'm saying head is 1/2. Tail means, no dear, see here, coin, no, right? I am tossing. Now, probability, I say heads, it is 1/2. Suppose if I say tail, 1/2 only. You got the point? Either it is head or tail, it is going to be 1/2 only because coin is having 2 sides. The result is going to be only 1. This 2 is nothing but head and tail. This 1 is denoting head or it can be a tail. It is going to be 1/2 only. So this method of studying by experimentation using sample space is what we call classical probability. Either you take a coin or either you take a dice. Okay, now if I roll a dice, I want 6. Okay, what is the probability of getting 6? 1/6. What is the probability of getting 1? That is also 1/6 only. Whatever, the number is going to be only 1. But die is having 6 sides, that's all. Here I'm using coin, 2 sides, that's why 1/2. If I say a die, 1/6. Whatever may be the number, the output is going to be 1/6. Coin 1/2 because it is having how many? This is how you need to study. How many sides first? Coin is having 2 sides, that's why 1/2. Die is having 6 sides, that is why 1/6. It can be any number. Okay, so this method is what we call classical probability. Then what is empirical? Now it depends on actual experience to determine its likelihood outcome. Like for example, you have data on number of people with different blood types, and we get the following. Like for example, you see B group 5 people, AB 2 people, O group 21 people, and A. Now, the probability that a person has type O is 21 by 50, which is 0.42. You know how we are getting? Very simple. 5 plus 2 plus 21 plus 22, how much? You add everything, count everything. See, 5 plus 2, 7, 7 plus 21, 28, 28 plus 22, 50. So they are asking O group, 21, 21 by 50, which is the probability it is calling as 0.42. Suppose if I ask what is the person has type B, 5 by 50. If I say AB, if I say A, the first one experiment, second one we are using people, blood sample type or whatever. We take the total and we come to a conclusion. So now you can understand the difference between classical and empirical. In empirical, data on number of people, we take it and we study the probability. Okay. So this is the sample space, dear. Sample space, if you toss a coin, one coin. If you toss, you have one head, one tail, correct? Okay. Now if you toss a coin 2 times, if you toss 2 times, tossing a coin twice, 2 head you will get, one head, one tail possible, one tail, one head, and 2 tail also possible. This is what we call sample space. When we toss twice, we are writing all this result. Same way, throwing a die. Die is having 6 sides. You know the die? We are throwing for the game. So throwing a die, the sample space, we have 6. Now throwing 2 die. Now 2 die you are rolling. Okay, it can be, result can be 1, 1, 1, 2, 1, 3, 1, 4. It can come. Or 2, 1, 2, 2 in this series. Then 3, 1, 3, 2 up to 3, 6. 4, 1 to 4, 6. 5, 1 to 5, 6. 6, 1 to 6. This is all what we call is a sample space. One coin is having head and tail, but 2 times you are tossing. It can be 2 head, can be 1 head and 1 tail, and 1 head and 2 tail. If you are using a die, die is having 6 sides. Then if you roll 2 die, this is the sample space we are going to derive. Okay. Still we didn't go to the problem. When I go to the problem, definitely inshallah you will understand. Okay. We have time. Do we have a time? Yes, we have. Okay. Now, let us understand the next one, events. Now, events is defined as subset of the sample space of the random experiment. You are doing a random experiment. Let us find what is event. Now, we give a sample experiment. See, consider random experiment of the following a die. Okay. Die is having how many sides? See, whenever I say die, please remember when we use for game, die will be like this. It will be a small square having 6 sides. Okay, just imagine, immediately come to a picture. Now, getting even number, what is the probability? You know, even number, die is having 1, 2, 3, 4, 5, 6 sides. Even number, how many? Even number 2, 4, 6. So what is the probability if it is even number? 3 by, that's all. That's all. That is the answer. See, even number is 2, 4, 6. This is what we call event. Event is you are saying it should be an even number. Even number, we know 2, 4, 6. This is what we call event. So what is the probability we get? 3 by 6. Okay. Let us take another example. See, this is clear, right? This is clear. Suppose instead of even number, if I say odd number, 1, 3, 5, again 3 by 6. Okay. Even number, it is 3. Odd number, also 3. But you should be very careful. One number, if we say 1 by 6 only, odd and even, then you need to be very careful. These are the events which is occurring. Okay. Now, one more example. There are 2 children in a family. How many children? 2 chiku. Okay. Find the event that both children are boy. They did not say, they say only 2 children, but how many boys? Both are boy, they are telling 1. Okay. Only 1 children is a girl. So 1 must be a boy, 1 must be a girl. There is at least 1 girl. So you need to find. So to do this, first we need to draw sample space. What we need to do? Sample space. They are telling 2 children, right? These 2 children, it can be both boys. Do you agree? You agree? You agree or disagree? It can be, B means boys. Please remember, B stands for boy. G stands for girl. Okay? They say 2 children. Both can be boy. Yes, possible. 1 boy, 1 girl, also possible. 1 girl, 1 boy is also possible. Both girls also possible. What is this? This is what we call sample space. Okay. Now you take the first question. What they are asking? Both are boys. Where you get both boys? So only one, right? So in only one case, we are getting event 1. Both children are boys is BB, the first one only. For the first question, this is the answer. Now see the second question. Only one of the children is a girl. It means one girl is here, another girl is here, and yeah, so you see here, but we take here the first one and second because they say only one children is a girl. They didn't say 2. This is event 1. This is event 2. Now, there is at least one girl. If they say like that, this boy and girl will come, girl and boy will come, this girl and girl will also come. This is the third one, event 3. So by giving a small example, 2 children, you see, this is what we need to calculate by sample space. Okay, it can be both boy, it can be 1 boy and 1 girl and 1 boy, both can be girls. So they say the first event, both children are boy. Yes, the first one only it is satisfying. And in the second case, only one of the children, one only should be girl. It means the second one, third one, we are taking in event 2. Third one, at least one girl. It means here you see girl is there, here also girl is there, and in the third one also we have. That one we take it in event 3. This is a simple example. Able to understand? Practically also how we are applying probability. So we'll continue this probability rules in the next class. I will stop up to this. Up to this, some theory is there. Then we will move into the problems. Okay.